Hello children, welcome again to EDUHUNT classes. Now we are going to continue the previous worksheet 3 bits right from 41 to 60. Okay. So here we go with the 41st question. Mixture of water and milk shows dash effect. We know mixture of water and milk. Milk comes under which solution? Milk comes under colloidal solution. Very good. So when this colloidal plus solution gives with water, what happens? It gives which effect? Very good, Tyndall effect. Option 3. So mixture of water and milk gives us Tyndall effect. It allows the light to pass through them, right? Okay. So 41 is option 3. Now moving to next 42nd question. Here we go. Colloid is dash mixture. We know all the colloidal solutions comes under which solutions? Very good, heterogeneous mixtures. Where is this? Okay, option 4. Okay, true solutions comes under homogeneous, and whereas colloid suspensions comes under heterogeneous solutions and mixtures. Okay, very good. Now 43rd question. Dash particles are scattered, a beam of light passing through it and make it pass visible. Children, what makes the path visible? Which light goes through the particular solution? We have options here: solute, solvent, colloidal, and none of the above. What according to you is the correct option? Which light, which particles are scattered and pass through the particular solution? What is that? Very good, colloidal solution. What about if it is not, path is not visible? If path is invisible, we will consider it as a true solution. If the path is visible, that is a colloidal solution. Okay? Yes. So option 3. Okay? Now, next. 44th question. Foam is the example of. Okay. Foam is the example of. What is foam actually? Foam is a mixture of gas. Foam is a mixture of gas and what? We discussed, no? Foam. Yeah, the shaving cream or else the nurga vastuni cheppam kada. What is that? Foam is a mixture of gas and liquid or solid? Liquid. Very good. Now, what is this now? Which solution is that? Absolutely, it is a colloidal solution. Will it comes under scattering light? No, they are asking us about the example, no? It's example of colloids, colloidal solution. Okay. Now, next question. 45th question. Here we go. We can separate the volatile component from its non-volatile solute. See, volatile component we have here and non-volatile solute by the method of. How can we separate, children? We discussed in the experiment, right? How to separate a dye, a colored component with that of the blue ink or black ink. We discussed over there, right? Now, what is the meaning of volatile component? Volatile component means which evaporates easily. And easy ga aviraipotundi kada? Yes, evaporates easily are known as volatile components. Okay. Now, what is non-volatile? Quite opposite, which does not evaporate easily. Very good. Does not evaporate. Okay. So, where we have this particular bit? 45th, we have extractions options. Extraction, separation, filtration and evaporation. So, what comes under this particular bit, children? For example, if I take this volatile product as a, let's say water, okay, and the non-volatile component in the particular experiment of the colored components of, dyes, colored components of black ink or blue ink, no, this is the black ink or blue ink, the solute we say, no, black ink or blue ink where only the dye, in that we have only the colored component, dye, that is termed as a solute. Then what about this solvent? No, dye is a solute over here, it does not evaporate, it leaves in the particular experiment, right? Then what about this water? Water is acting as a solvent in that particular experiment. You remember? Yes. So now what is the correct option here? It is option for evaporation, right? So we can separate the volatile components, which means the solute, okay, sorry, solvent, from its non-volatile solute by the method of evaporation. You know, evaporation by adding the temperature, by heating the purpose. If you heat the black ink or blue ink, what happens? The water component evaporates easily, తొందరగా ఆవిరైపోతుంది, and leftover component will be ink, అంటే the dye అంటాం కదా, colored component, dye మిగిలిపోతుంది కదా. So then we can separate the non-volatile solute from this non-volatile, completely volatile solvent, okay. Now here we have next question. Solid particles are not soluble in solution. Okay, there are some solid particle systems, and that solid particles are not soluble in solution systems. Okay, there is a solution where the solid particles are not completely dissolved. అంటే అది ఒక సొల్యూషన్ ఉంది, ఆ సొల్యూషన్లో ఒక పార్టికల్స్, సాలిడ్ పార్టికల్స్ అవి కంప్లీట్గా అవి డిజాల్వ్ అవ్వాలంటే ఈజీగా కరిగిపోలేదు. ఓకే, వీ కెన్ సీ సాలిడ్ పార్టికల్స్ ఇన్సైడ్ ద సొల్యూషన్. అప్పుడు that can be separated by what process they are asking us. General example, ఇప్పుడు టీ తెలుసా మీకు? టీని మనము తాగకముందు ఏం చేస్తాం, దాన్ని ఫిల్టర్ చేస్తాం కదా. ఎందుకు ఫిల్టర్ చేస్తాం? ఆ టీలో ఉన్న టీ పొడి ఉంటుంది కదా, టీ పొడి చిన్న చిన్న పార్టికల్స్, బ్లాక్ కలర్ సాల్ట్ పార్టికల్స్ ఉంటాయి కదా, అది పాల్లో వేయగానే దానికి ఉన్న కలర్ అంతా పాలకు వచ్చేస్తుంది. సో వైట్ కలర్ మిల్క్ టర్న్స్ ఇంటూ సమ్ బ్రౌనిష్ కలర్ ఆఫ్ ద పర్టికులర్ టీ, రైట్? So what happens if you want to sip that tea? What happens? Before we will filtrate. Filter చేస్తాం కదా, అప్పుడు ఏమవుతుంది? ఫిల్ట్రేట్ పైన ఆ మెష్ కిందకి లిక్విడ్ వెళ్ళిపోతుంది, అంటే మిల్క్ అంటే టీ వెళ్ళిపోతుంది. లెఫ్ట్ ఓవర్ విల్ బి టీ పొడి పైన ఉండిపోతుంది కదా, దట్ ఈస్ ద వాట్. ఓకే, హియర్ సాలిడ్ పార్టికల్స్ ఆర్ యాక్టింగ్ యాజ్ అ ద టీ పౌడర్ అండ్ సొల్యూషన్ ఇస్ నథింగ్ బట్ టీ. ఓకేనా? సో అలాంటి కండిషన్లో హౌ వీఆర్ గోయింగ్ టు సపరేట్ దెమ్. ఇప్పుడు టీ తాగాలంటే ఆ మొత్తం టీ పౌడర్, ఆ మిల్క్ అదంతా ఉంటుంది కదా, మిక్సింగ్ ఆఫ్ దాట్. సో మనం తాగినప్పుడు ఏమవుతుంది, టీ పౌడర్ మనకి తగులుతుంది కదా. సో తగలకుండా ఏం చేస్తాం, వీ విల్ జస్ట్ ఫిల్ట్రేట్. ఓకే, ఫిల్టర్ చేసి తాగుతాం. సో ఈజీలీ వీ కెన్ జస్ట్ అవాయిడ్ ద అన్వాంటెడ్ సాలిడ్ పార్టికల్స్. సో హౌ వీఆర్ గోయింగ్ టు సపరేట్ దట్ వీఆర్ ఆస్కింగ్ నవ్. వాట్ ఈస్ దట్ ఆన్సర్? వీ హ్యావ్ ఆప్షన్స్: ఎక్స్ట్రాక్షన్, separation, filtration and evaporation. Now tell me. Very good. The answer is filtration. By filtration process, we can just separate the solid particles which are not dissolved in the particular solution. Okay na? For example, మీకు ఒక glass of water ఇచ్చి కొంచెం I gave you the sand ఇచ్చాను, ఇసుక. ఓకే, ఇసుక ఇచ్చినప్పుడు ఏమవుతుంది, కరిగిపోతుందా? వాటర్లో శాండ్ మొత్తం కరగదు కదా. అప్పుడు ఏం చేయాలి? ఇఫ్ యూ వాంట్ టు సపరేట్ దట్స్ బోత్, వాట్ హ్యాపెన్స్? జస్ట్ ఫిల్టర్ చేసామనుకోండి, వాటర్ వచ్చేస్తుంది. left over small particles ఉంటాయి కదా, solid particles which does not dissolve in the particular solution. What happens? It will left in the particular filtrate కి పైన అతుక్కుపోతుంది కదా. It's what separation of filtration. Okay, got it na? Okay, next bit. Question number 47. Which of the following method can be used to separate a mixture of camphor and sugar? This is a repeated bit, na? Yes, no? Camphor and sugar experiment is also there. By what process can we separate the camphor from sugar? Which process? Tell me. We have options here: sublimation, filtration, distillation and crystallization. Very good. Option 1, sublimation. Wherever you see camphor, it gives you the word answer sublimation. No, before previous which we have this solved. Yeah, okay. Next question, question number 48. The process of separation of insoluble solids from a liquid is called, oh, same bit but asked a different way. Previous 46 question కూడా సేమ్ ఇలాగే ఉంది, బట్ డిఫరెంట్గా అడిగారు ఇక్కడ. ఓకే, ఏమంటున్నారు? ఇన్సాల్యుబుల్ సాలిడ్స్ అంటే కరగలేని సాలిడ్ పార్టికల్స్ లిక్విడ్లో ఉన్నాయనుకోండి, How we are going to separate that? The process of separation is called filtration. Very good. Awesome. You got it. Okay. Now, shall we do the next question? Yes. Question number 49. If a solution contains 60 grams of common salt, which means it is a table salt, NaCl, right? Yes. In 340 grams of water, the mass by mass percentage will be, okay, this is about the formula one, right? So we have here the given question contains, see first I'll write the given one. We have given mass of solute is equals to how much, children? What is solute over here? What is solute? ఇక్కడ solute లో ఏముంది? ఏమి ఇచ్చారు అక్కడ? We have common salt. Common salt. We can also write this as a formula NaCl. Very good. So it is how much? Is equals to how much grams? 60 grams. That is a mass of solute. Okay, we got it here, right? Now, what is next? In 340 grams of water. So what is the water now? Mass of solvent, right? Mass of solvent. What is solvent over here given? Water. Very good. What is water formula? Chemical formula? H2O. Very good. Good. Now we have here how much? 340 grams. Right? Correct? Yeah. So now we have to find out the mass by mass percentage. What is the formula, children? Mass by mass percentage? Mass of solute by mass of solution. Okay. So if we want to calculate mass of solute by mass of solution, we have to first find out what is the mass of solution. As we know the formula, mass of solution is equals to mass of solute plus, come on, tell me, solution is equals to solute plus solvent, right? So mass of solution is equals to mass of solute plus mass of solvent. Mass of solvent, right? Okay. Here we have the solution. We have to find it out. Okay. So what is the mass of solute, children, over here? 60 grams. Very good. What is the mass of solvent? 340 grams. Very good. Gives rise to how much? It gives rise to 340 plus 60. How much? 400 grams. This is the required mass of solution. Okay. So if I want to continue the particular sum, I'll just add the page. Okay. I'll just write over here, children. Okay. Now, if you want to find out the mass fraction, okay, what is the formula given? What is the formula? Mass of solute by mass of solution, not solvent. It is mass of solute by mass of solution. Okay. If they ask in percentage into 100, just see the options. Okay. It is given in the clear cut, no? Okay. So we have here mass of solute by mass of solution. What is the mass of solute given, children? How much? 60 grams by mass of solution. As we calculated, 340 plus 60 gives rise to 400 grams. Okay. If we do the cancellation process, 0, 0 gets cancelled. Okay. And now what happens? 2 table. Okay. 2 3s and 2 20s. Any more calculations, children? We got here it is 3 by 20, which gives rise to 0.15. Okay. If we want to calculate in percentage, what happens? Into 100. Okay. If it is mass percentage, I'll just write here. Mass percentage, it will be equals to into 100, no? If it is into 100, what happens? Answer will be 15%. Okay. But in the previous question, if you see, they gave us in the decimal format. So we have to just try with the options given. Okay, here it is 0.15. If they ask us in percentage, we can write here it is as a 15%. Okay, then the answer will be 0.15 or 15%. Okay, that is a mass by mass percentage. Okay, mass by mass percentage. We'll write now simply bracket m by m percentage. Yes, that's a formula. Okay, clear, right? So option is 2, 0.15, the mass by mass percentage. Okay, children, if they ask us in any other format, like with the help of this solute and solvent, we have to first add the solution, right? After adding the solution, then only you have to do calculate not particular formula. Okay, simply you should not do 60 by 340, wrong, because this is solute, no, this is solvent, right? So we should not do by this 2, we should add 60 plus 340 first to get a solution, mass of solution, and then we have to continue to do the formula wise. Okay, na? Don't just go with the hurry burry. Okay, good. Now moving to next question, question number 50. During sublimation of ammonium chloride, what is ammonium chloride? Ammonium chloride formula NH4Cl. Okay, ammonium chloride is NH4Cl. Very good. Okay, during sublimation of ammonium chloride, pure ammonium chloride gets. Okay, this is the given experiment wise. We just go with the option. Okay, first one, liquefies to form a solution, collected on outer side of the funnel, collected on the inner side of the funnel, sorry, inner side of the china dish, and fourth one, collected on the inner sides of the funnel. So remember the experiment, the sublimation one, taking a Bunsen burner, tripod stand, wire gauze upon a china dish, adding some ammonium chloride salt solution, sorry, particles, and then upon that we just inverted funnel, placement inverted funnel. Then you could light up the Bunsen burner. The ammonium chloride will just sublimes, in the sense solid to gaseous state. Sublimation is nothing but solid to gaseous state, no? The solid particles of ammonium chloride will just go sublimes to the gaseous particles, no? Then what about this, the gas containing of ammonium chloride, pure ammonium chloride, after going towards the funnel upside, what happens? There, because of the cooling surfaces, the pure ammonium chloride is collected, no? So where it is collected? It is collected outer side or inner side of the china dish or inner sides of the funnel. Where is that? It is inverted place, no? Do you remember that experiment, children? Yes, yes. So this is a Bunsen burner. Okay, and upon this it is tripod stand. Yeah. Upon that, what is that? Upon that we are placing wire gauze. Very good. And upon wire gauze, what happens? We just placing a china dish. Okay, china dish. And in the china dish, what we are adding? We are adding the ammonium chloride particles, the solid form of ammonium chloride particles, and upon that what we are doing? We just placing the inverted funnel. Inverted funnel is being placed inside like this. So what happens? When you light up the Bunsen burner, okay, when you light up the Bunsen burner, it glows, no? What happens? The flames hit the china dish. This wire gauze gives the equal amount of heat to all the around china dish basement, and the ammonium chloride particles will just go sublimation, means solid to directly gaseous format. And in that case, what happens? There is a cooling. This place is giving a cooling surface, right? So the particles which are subliming will just go attached to the inner sides of the walls of the funnel. Then we can just take out the pure ammonium chloride. Okay, so this is what the experiment goes on, and here we are going to collect the pure ammonium chloride on the inner sides of the funnel. Okay, not about the inner side of the funnel dish, not about the outer side of the funnel. How can we calculate outside the funnel? No, not about the liquefaction form. There is no liquefied. Okay, liquefaction is what, children? In the liquid state, no? But is it going to liquid state from solid to liquid? Is there any from solid to liquid going on? No, no. There is no such formation of solid state to liquid state. Directly to gaseous state. Okay. There we can observe the sublimation of the pure ammonium chloride particles in the inner sides of the funnel. So, option will be option 4. If you just remember the experiment of ammonium chloride sublimation, you just easily do that. Okay. So, just go with the experiment revision concept and just do the bit again. Okay. There you have the particular picture, and also we place some display some pictures also, no? Okay. Clear, right? Okay. It is formed on the inner sides of the funnel, right? It's all about the sublimation of ammonium chloride. Okay. And here we have question number 51. During filtration, the solid that remains on the filter paper is called. Okay. So, we are going to do the filtration process. Okay. Upon that, we are going to take filter paper, which is like a similarly with like of tissue paper, but not in that same texture. We have different texture of filter papers. Okay. So, what happens? We are going to filtrate that, right? Upon filtration, the particles which remains ante migilipoyindi deni meeda filter paper meeda remaining migilipoyindi untadu kada danni em pilustamani cheptunnaru. What we will call that? As residue. Very good, you got it as residue. Solid kaadu, solvent kaadu, filtrate kuda kaadu, it is nothing but residue. Okay. Option is 2, right? Question number 52. More than one kind of pure form of matter combines form dash. See, one or more than one kind of pure form of matter combines forming dash. Options we have: texture, solution, mixture, component. Come on, matter, classification of matter into pure substances and mixtures, right? Yeah, very good. So, we have the matter classification. Matter is classified into 2 broad categories, where first one is nothing but pure substance, and next one is, what is that next one, children? Mixture. Very good. So, in pure substance, what we are dealing? Pure substances which are made up of only one kind of particles, only one kind of particles, they are made up of only one kind of particles. Okay. Then what about mixtures? More than one kind of particles, which means combination of 2 or more particles, we can say. Okay. Such that we can say mixture is a matching answer for that of question number 52. Okay. So, if it is asking only one kind of particles, it will be pure substance. But here it is given that more than one kind of pure form of matter combines to form what? Mixtures. Very good. Option is 3. Clear now? Very good. Now, question number 53. Dissolved sodium chloride can be separated by water from water by. Okay. See, sodium chloride is nothing but salt. Okay, I'll write here. Sodium chloride is nothing but salt. Which salt? Common salt we can say, table salt we can say. Okay, what is the formula now? NaCl. So, this is dissolved. Okay, dissolved sodium chloride can be separated from water by. So, what it is dissolved now? This particular sodium chloride is dissolved in water. Okay. So, how we are going to separate that, they are asking us. So, if after dissolve of this particular sodium chloride in water, what happens? This is acting as a solute, this is acting as a solute, and this is acting as a solvent. We know, if we take some amount of water and if we add some salt, sodium chloride, what happens? It will easily soluble. Karigipotundi kada salt, uppu karigipotundi kada water lo. So, what happens? We want to separate that. Separate cheyalanko. Ela chestam separation? By the process of evaporation. Very good. So, that is the answer. But here we have the options. Let's do chemical process, physical process, chemical process of extraction, physical process of evaporation. What is the answer, children? Experiment 1 only. Physical process of evaporation. Because why physical process? Just heating. Evaporation ante enti? Heating e kada. So heating is nothing but a physical process. Clear now? Of evaporation. Get it? Okay. Now next question. Question number 54. Non-uniform composition of solutions called as dash solutions, which are not uniform. Come on, tell me. What comes under non-uniform compositions of solutions? We have mixtures classification, right? Matter is divided into two. Matter into two. Pure substance, mixtures. And in mixtures we have two again. What is that? In mixtures classification we have homogeneous mixtures and heterogeneous mixtures. Yes. Homogeneous and heterogeneous mixtures, right? In homogeneous mixtures, what about the homogeneous and heterogeneous? Homogeneous are nothing but which are having the uniform compositions. అంటే ఒక్కసారి మిక్స్ అయిపోతే ఆల్ త్రూగా ఒకేలా ఉంటుంది కాంపోజిషన్ కదా. Composition, okay. For example, let's say salt water, sugar water, okay. And what about heterogeneous compositions, children? Which are non-uniform. అంటే example, let's say muddy water, sand water, అలాంటివి ఏమవుతుంది? Which are having visible boundaries. అంటే క్లియర్గా మనకి బౌండరీస్ తెలిసిపోతుంది కదా, ఇది శాండ్, ఇది వాటర్ అని. బట్ సాల్ట్ వాటర్, షుగర్ వాటర్లో ఏమవుతుంది? డిజాల్వ్ అయిపోయాక తెలియదు కదా. ఇట్ ఈస్ హ్యావింగ్ అ యూనిఫామ్ కాంపోజిషన్. వాట్ అబౌట్ heterogeneous? Non-uniform compositions. Okay, what is the answer now? Read the question once again. Non-uniform compositions of solutions called as solutions. Heterogeneous solutions. Okay, clear now? So solutions are like that only. We have mixtures like solutions also. Okay, so in that case, if it is having non-uniform, we just tell it as heterogeneous solutions. Homo means true solutions. Okay, heterogeneous comes under colloidal solution suspensions. Okay, clear? Question number 55. Uniform compositions of solutions called, just now we discussed, what is that? Answer, come on, tell me fast. Homogeneous. Very good. Option 3. So uniform is homogeneous, non-uniform is heterogeneous. Good. Now homogeneous solutions may separated by, okay, example of homogeneous solutions are examples. What are examples of homogeneous solutions? Come on, tell me. Salt water. We have example just previous bit, no? Sugar water, salt water, ammonium chloride. How are you going to separate that from the atom water? Which process? Evaporation. What is that? Physical process or chemical process? Physical process of evaporation, right? Clear? But they ask in different question manner, but the given options is same. Okay, so fine, we have the homogeneous separation of taking place by physical process of evaporation. Good. Question number 57. Mixture of two or more metals or metals and non-metals is called as. Children, just tell me what is a mixture of two or more metals called, what we call them as. For example, let's take brass, bronze. You know brass? Brass is a mixture of copper plus zinc, right? So we also have bronze. Bronze metal istar kada, third place vastayi, gold, silver, bronze. Bronze. So bronze is a mixture of copper plus tin. Into the tin. So write the names. It is a mixture of copper plus zinc. This is copper plus tin. Into the tin. Why SN ante? SN is the having the Latin name stannum. Okay, that's the name SNN. Sorry, stannum the name. Okay, INNUM maybe. Okay, so tin is having the stannum as the Latin name, so the symbol is SN. Okay, so here we have two or more metals or two or more metals with non-metals, okay. If the mixture is going to happen, what is that mixture is called as? It is called as a, options we have alloy, solution, mixture, metallic mixture. Not metallic mixture, okay, because why? We also have non-metals, no? What is option of? Solutions means mixing of two or more components, in the sense mixtures maybe, or else pure substances maybe, yeah, okay, but not matching, okay. What about mixture? Not about the metals and non-metals, okay. That is option of alloy. Alloy means it is mixture of two or more metals or metals with non-metals. That category is called as an alloy. What is that, children? Repeat after me. Alloy, okay. Examples are brass and bronze, okay. And we have 58th question. Alloy cannot be separated by dash method. Okay, alloy cannot be separated by dash method. Tell me. Alloy anadi mixture of two or more metals or metals with non-metals kada. So adi dein valla separate kaaledu. Okay, we have options here. Chemical process, chemical method, evaporation method, extraction method and physical method. అది సింపుల్గా తేలిపోయే పని కాదు కదా. సో దేనివల్ల సాధ్యం కాదని అడుగుతున్నారు. టెల్ మీ. ఫిజికల్ మెథడ్, వెరీ గుడ్. సో ఫిజికల్ మెథడ్ అది అసలు సపరేట్ అవ్వలేదు, ఓకే. దట్ ఈస్ రీజన్ కెనాట్ బీ డన్, ఓకే. కెమికల్ ప్రాసెస్తో చేయొచ్చు, బట్ అలాయ్ కదా, మిక్చర్ ఆఫ్ టూ ఆర్ మోర్ మెటల్స్ ఆర్ నాన్ మెటల్స్ కదా, అంత ఈజీగా అవ్వదు. దేంతో? ఫిజికల్ ప్రాసెస్తో, ఓకే. క్లియర్నా? ఓకే. నెక్స్ట్ 59th question, children. Okay, brass is mixture of dash and dash. Come on, tell me, you know the answer already. ఇప్పుడు చెప్పాను కదా క్వశ్చన్, ప్రీవియస్ క్వశ్చన్, 57th question I guess. చెప్పండి. Brass is mixture of copper plus zinc. Very good. Where do you have? We have two options, 3 and 4 both are matching. Okay, zinc and copper, zinc and copper. Sometimes the options are like that, okay, fine, don't worry. Zinc and copper are the mixtures of giving brass alloy, okay. Question number 60. Same question to answer and answer to question. Zinc and copper get mixed by forming steel? No. Gold? No. Zinc carbon mixture? No. What is that? Brass, okay. So this is a particular 60 bits for you from 41 to 60. In the next video, we are going to continue the bits from 61 to further, okay. So here is the session, children. Thank you.